Okay, Ryan, here's what I found today up at the company that makes the rapid prototyping machines here in Colorado. They build the TAS machine. So anyhow, here are these translucent colors. So this is kind of a weird shape here, very thin wall. It's made out of a nylon, so this is a nylon 6/6, very rugged. You can dye this, so they were showing us how they dye it, and it's pretty cool. Here's a red one, and let's see if I can get the translucency to go through this. It's kind of hard to see that. Anyhow, I'm going to send you these samples, and this is what's coming across to you. Here's a yellow one. Oh, that was this was the PET. The red one was the PET, but they like the nylon for transmitting light. Here's an ABS, and let's see how this lights up. So that's kind of a yellow filament there. They had all different colors of filaments. Here's a larger part. There's a larger part right here. So this is again this is the PLA. So anyhow, there's all these samples that'll be coming across, and you can kind of see what they're doing. They're real thin wall, really cool shapes that made me think of you guys. So anyhow, I've got samples, and I'll ship them out in the morning. And here's the rest of the show. I hope you like it, and have a great day. All right, we're sitting here talking about, what's the gentleman's name that's doing all this?
Well, he goes by the name of Rich Rapp.
Rich Rapp.
His name is Rich. I don't remember his last name.
And Ben's here, and you're talking about the nylon and why you think that this would be a good element for transmitting light. It's very strong.
It's obviously very strong.
And then you can dye it.
And it can be dyed. And just by itself, I think it transmits light beautifully.
All right, beautiful. Thank you. Here's the farm. All these guys going.
Oh, so see these little boxes on the side?
Yeah.
Those are the Beagle Bones.
Right.
So those are actually running.
So it's all Ethernet to USB conversions there. Mm-hmm. Nice. So it goes into some kind of Ethernet switch. And
what are they all casting here?
They're printing parts to build more printers.
Yeah. So they're parts for the printers.
So which part is this? I'm curious about which part does that look like to you?
What have we got here? Look at this. Oh, unbelievable. The new world that we live in. Look at this. Unbelievable. Whoa. This is the future. 3D print farm. Big build windows. All running Arduino.
Yeah, that's gonna be a thing to kill.
They're everywhere. Unbelievable. Robots are taking over the world. Wow, this is the future, boys. Isn't it? Awesome. We came up from Colorado Springs to check it out. Thank you, yeah. I own a MakerBot, but I'm ready to burn it in the fire pit. It's one of the old wooden ones.
Yeah.
I've been fighting that thing day in and day out. So what's your reliability like here on these guys?
We got 135 of them right here.
135 units.
They're, we got about 85% of them online, completely and operational at any one time.
All right. Cool. So
keep in mind that we're running about 2/3 of the 24-hour shift rate.
Yeah.
So we beat them up pretty hard.
Yeah.
We're actually an arm of R&D. We get all of the
life cycle studies.
Anything that comes back, that's refurbished, stuff like that, ends up usually in here.
Cool.
So we get the worst of the worst, and we still
put them right back in and get them going.
Right back in and get them going. Yep.
Nice. What's the mean time between failure on something like this?
There's a couple of parts, a couple of moving parts that are a little higher risk than others, just that we see across 100 printers over time. But I don't even.
A couple thousand hours.
Yeah. I mean, thousands of hours.
Thousands of hours before you got to service them.
Yeah.
Cool.
And most of those changes, most of those services are single parts, one gear, one tube or something, you know, tiny little things, like 5-minute fix.
We've had what? One motor fail?
One motor's failed.
One.
In the whole room.
Of the operation.
Really?
Room.
Wow.
No, I mean, ever. Ever.
Yeah.
Ever.
From a client, no client has ever
No one's
reported a
returned.
motor. We did have the failure occurred in here.
Really?
Got in here.
Wow.
We run the printers hotter, longer than I imagine anybody.
Yeah, I
else
could
out
never
there
get
in
the
field.
temperature up on my MakerBot. You know, for some of the stuff, it was always too cold, and you know, I was just struggling with it. Looks like a more robust machine. Is there a reason why there's cabinets here? Does it help hold the heat in?
Because we have so many machines, we took a look at how the thermal properties benefited us to keep it hotter, cooler, etc. And we decided that rather than have variance in temperature throughout the day for breezes and things like that, just enclose them so that we didn't have to stress about it. So I would suggest if you're doing volume, a cabinet like this is not a bad idea.
Cool.
If nothing else, it gives you an environment that you can thermally control another way, right?
Right, sure.
You put an exhaust fan on the top of it if you want to, a little temperature sensor, whatever.
What are the power supplies doing in here? I see them kind of scattered around. Back there, looks like a power supply.
Yeah, that's the actual power supply for the printer.
Oh, okay.
So it's an external power supply.
Right.
I'm going to stop this one and see it running a little bit on its own there.
Nice.
Well, not on its own, but somewhere there in that landing section.
So they're making parts to make the machine. Cool.
Oh, you're working on that one?
Unbelievable. So you guys probably have quite a job just keeping up with all the code here.
Keeping up with what?
Keeping up with all the programs, launching all the code.
Yeah.
So what programs do you use to generate your Decode? I own a CNC, a couple CNCs, and I was just curious because I was using SignForge,
It's mostly Slicer.
Slicer.
Yep.
Yep.
We use, what is it? OpenCAD?
FreeCAD.
FreeCAD, thank you.
FreeCAD and Blender.
FreeCAD and Blender are the
FreeCAD.
two. They're both open source applications.
Right.
You know, so Blender's amazing. It's actually a rendering tool.
Yeah. So how long will it run with just one spool running wide open?
A while.
Couple days?
No, we probably get, I would say, off of any given printer, 2 weeks maybe?
Yeah.
2 weeks in between changing out the reels?
Yeah.
The 7th reel and swapping today. We
Right.
have it in a couple of days.
Yeah, so that's 7 out of, what, close to 120 printers, right?
Right. Awesome. Thank you very much.
Yeah, for sure.
Okay, look at these are lamp covers here on the Taz. So this Taz cost $2,200, and it's doing a nylon, so it's really durable here. And build window is 12 by 12 by
Like 12 by 11 by
12 by 11 by 10 inches. So 300 millimeters X, Y, and Z. And this is a glass plate here. It's different than the MakerBot that I've got. These are bigger shafts and leader screws here, so very similar to what I was running. They can do a 2-head print where they can mix the colors in here. But this is the Taz, and anyhow, these guys are here in Colorado. So pretty cool. This is kind of a neat structure.
I'm the kid that used to wander off and get lost in the museum. Yeah, I like whatever that black kid did.
This, I think it's just like that. Wolverine block.
Ah,
Superhero.
see, it's not a real thing. It's a
Look at the flex.
as opposed to these things.
Yeah, exactly. Well, it's not going to
It's 2 colors.
Now the two color effect. Look at this back.
Yeah, look at the
Here's
the swirl.
two color. Oh, I see. That's one color.
It's awesome.
No, look here. Pay attention.
Oh yeah, look at that. Wow, that's beautiful.
Yeah, so this was done with, and actually,
Oh, that's a soft one.
so that's the Ninja Flex. Yeah.
Wow. So the machine made those colors there, and you've got a routine to be able to make the
To be able to
transitions the
switch-
way
to
you
be
need
able
to make
switch
it.
between colors, yeah, you can do that with the dual extruder. That one was actually done with a single extruder. So they just no,
This one,
they both
kept changing the.
they just would pause it and swap.
Wow, very cool. So this is PET, right? It's PET. So what's the package that you're designing in?
Well, at home I'm designing in Cinema 4D, but I don't use that here.
What is it called?
Cinema
4D. What do you use here?
Here I use Blender
Blender. Cool.
because it's open.
Yeah, it's all open source. What cool shapes.